Let's take a look at fractions. At this time, I'm presuming that you are fully familiar with basic numbers. Like you understand what this number means. Do you understand what 13 means? Do you understand what 17 means or 75 means and so on? You're also familiar with negative numbers. Like you know what this means, you know what minus 11 means, you know what minus 25 means and so on. And you understand, of course, that all numbers are nothing more than points on a line that we call the number line or the number axis. If this is given the number 0, you mark off equally spaced points to the left and to the right. And this number 2, this is point 1, point 2, point 3 and point 4. The number 2 lies right over here. 13 will lie somewhere here, 17 somewhere there, and 75 way out there. Minus, these numbers are negative numbers, minus 1, minus 2, minus 3, etc. So minus 9 will lie somewhere here, minus 11 somewhere beyond that, and now minus 25 beyond that. So I'm making a presumption that you are quite familiar with basic numbers, okay? Let's take a look at numbers that you might encounter that look like this. These numbers are also numbers, very valid numbers, and they are called fractions. Now the reason they are called fractions we will see later on. Right now, let's take a look and see how we can verbalize these numbers. This number can be verbalized as 3 upon 7 or 3 divided by 7 or 3 divided into 7 or 3/7. However, the best way to verbalize these numbers so as to bring out their true meaning is 3 out of 7. Let's recap. A number of this type can be verbalized in many ways. 3 upon 7, 3 divided by 7, 3 divided into 7, or 3/7, or the best way by far is 3 out of 7. Remember this format, 3 out of 7. Let's take another example. I won't change this, but let me change the numbers over here. 7 upon 11. A number of this type can be verbalized as 7 upon 11, 7 divided by 11, 7 divided into 11, or 7/11, or the best way is 7 out of 11. One final example. 6 upon 17, 6 divided by 17, 6 divided into 17, or 6/17, or the best way, 6 out of 17. Remember this out of format. Now, let's take a quick look. If I give you 7 out of 11 objects, I'm not giving you the full 11 out of 11. Is that correct? I'm not giving you all 11, I'm only giving you 7 out of 11. Because I'm giving you a portion of the 11, and not the full 11, I'm giving you a portion of the 11, that portion is a fragment. It's a fragment of the 11, and therefore we call it a fraction. It's not the whole thing. It's a fragment of the whole thing, therefore we call it a fraction. This number can be verbalized best as 6 out of 17. If I had 17 items, and I give you only 6 out of 17, I'm not giving you the full 17, I'm giving you a portion of the 17. That portion or that fragment is called a fraction. And because I can give you 7 out of 11 objects, and I can give you 6 out of 17 objects, such numbers are called proper fractions. These are proper fractions. also called true fractions. Take another example. 7 nines. Can I give you 7 items out of 9 items? Sure can. Am I giving you all 9? No. I'm giving you a portion of the 9. A portion or a fragment. Therefore, this is called a fraction. That's exactly why these numbers are called fractions, because you are not getting the full amount, you're getting a portion of the full amount. Therefore, they are called proper fractions or true fractions. So far, so good? Alright. How about you have a number of this type? Initially, we had something like 7 out of 11. True fractions, I can get 7 out of 11, that's okay. Sometimes you'll come across numbers like this. In how many ways can you verbalize this one? 11 divided by 7. 11 divided into 7. 11 upon 7. Try to verbalize this as 11 out of 7 and you run into a bit of an illogic situation. 11 out of 7? Can't do that. I cannot give you 11 out of 7. And because of this illogic perceived when you try to use the out of reasoning, fractions of this type I call improper fractions. Seven out of 11 is a proper fraction. I can give you 7 out of 11. It's a proper fraction because I'm not giving you the whole thing. 11 out of 7 makes no sense. Therefore, it's called an improper fraction. So how do we actually refer to these? We refer to these by the other ways. 11 divided by 7 or 11 divided into 7. And the 11 out of 7 makes no sense, therefore they are called improper fractions. So far so good? So, proper fraction, improper fraction. Proper fraction, improper fraction. So far so good? Let's go ahead. Just as you can add simple numbers like 7 plus 11 gives you 18 and so on, you can also add up fractions. Let's, for example, try this out. For now, I've kept the bottom numbers the same. The above numbers, the upper numbers are called the numerators, and these numbers are called the denominators. For now, I'll just call it the upper number and the lower number. For right now, I'm keeping the lower numbers the same. So, the question is, what is 2 upon 11 plus 4 upon 11? If I give you 2 out of 11 items, and then I give you 4 out of 11, I've given you a total of 6 out of 11 items. If the bottom numbers are the same, you retain the bottom number right here, simply add up the top numbers. Now, at this point you might encounter a bit of an illogical situation. If I give you 2 out of 11 items, I only have 9 left. I don't have the full 11 left. So if I give you 2 out of 11, and then I give you 4 out of 11, how's that possible? I only have 9 left. Don't worry about that for now. In all of math, there are some situations called paradoxes, which means illogical situations. There's no explanation for them. For right now, please accept the situation that if the bottom number is the same, I simply retain the bottom number right here and add up the top numbers. So 2 11ths or 2 out of 11 plus 4 out of 11 gives me 6 out of 11. Let's take another one. 7 17ths plus 6 17ths. The bottom number is the same, simply add up the top numbers. 7 plus 6 is 13. out of 17. Now please